Hello there, our wonderful viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That channel is specially created for you and I to come together to tackle mathematics and demystify the age-long phobia often associated with this important subject, one topic at a time. It's my singular pleasure to welcome you and appreciate you for being faithful subscribers. Now, we are looking at the topic differentiation in past videos, whereby we have looked at the concept of differentiation, which is popularly called divided x. From then we move to the limit of a function, and thereafter we examine the concept of continuity of a function at a given point x equals to a. We are taking it a notch higher today by looking at the very important aspect of this topic, and that is the first principle. As the name implies, the first principle is by definition the very beginning of dy dx. So by definition, given that y is a function of x, that's y equals f of x, then dy dx by first principle is defined as a limit as delta x tends to 0 of f of x plus delta x minus f of x over delta x. So everything we do basically on first principle is going to be exclusively based on this definition. Without wasting more time whatsoever, let's swing into action and solve these two examples by first principles. So everything we do must reflect the first principle. So in essence, what we are going to do is, like the formula, we are going to add a delta x. This is the original function f of x. So we are going to say step 1, introduce delta for both letters. So for y, we're going to have delta y, and for x, we're going to have delta x equals 5. Then in lieu of x, it's going to be x plus delta x, then plus 2. That's step 1. Meaning we have created an f x plus delta x. So by definition, the next thing is what? We are going to subtract f of x. And y of x is what? 5x plus 2, which is actually 1. So the next step will be 1 delta y equals to 5 bracket x plus delta x plus 2, which is the original, which is the step there, then minus y. So what we have simply done here is we have taken away f of x, and this is 5x plus 5 delta x, open the bracket, plus 2, minus y being originally 5x plus 2, that will be minus 5x minus 2. Because we have plus and plus here, so we have minus, that will be minus 5x and minus 2. So what we have done here is we have done f of x plus delta x here minus f of x. So the next thing by definition is divide through by delta x. But before then, let's collect right terms here. So 5x minus 5x is gone. Then 2 minus 2 is also gone. We are left with just 5 delta x. So the next thing is divide both sides by delta x. That will be 5 delta x over delta x, which is actually 5. So what we have done up to this point is simply the contents of the bracket, which is f x plus delta x up to this point, then minus f of x, which is actually y. And then after the subtraction, we now divide through by delta x, and we are here. So the last thing we now do is to set all these parentheses to limit. We now say that limit as delta x tends to 0 of the entire function means limit of this, of this, which simply is what? 5. So invariably, we are having that dy dx is 5 for that question. So mentally, if you look at our very first video, we get the differentiation is basically without first principles is as good as just having 5, which is at least with that. Okay, I think that's quite straightforward, as I believe. Let's look at question number 2. Question 2, we have y equals 5 plus 4x minus 3x squared. So we know mentally that if we differentiate this, divide this, our answer is going to give us 4 minus 6x. We know this from our previous experience. So let's now go through first principle. So first principle, as usual, we introduce deltas. Delta y equals 5 plus 4, that is x plus delta x as well, minus 3 bracket x plus delta x all squared. So just as you introduce delta y, you must simultaneously introduce delta x. The next thing you do is to simplify the right hand side, and that gives 5 plus 4x plus 4 delta x minus 3. Expanding this, we're going to have x squared plus 2x delta x plus delta squared x, which in turn, opening the bracket, results in minus 3x squared plus, minus 6x delta x minus 3 delta squared x. So this is just right hand side. So the next, what we have done here is to simply have this f of x plus delta x. The next step is to subtract f of x, which is y. Therefore, delta y equals to 5 plus 4x plus 4 delta x minus 3x squared minus 6x delta x minus 3 delta squared x minus our y. This is our f of x. So we simply have minus 5 minus 4x then plus 3x squared. So at this point we can cancel out like terms. To start with, 5 minus 5, that's gone. We've got minus 4x plus 4x, that's also gone. Then last we have minus 3x squared plus 3x squared. So we are left with 4 delta x, then minus 6x delta x minus 3 delta squared x. These are the three things we have left. So we have actually solved just the numerator, which is fx plus delta x minus f of x. So the next thing is to divide through by delta x. It's going to become by delta x, delta x, delta x. And that results into 4. Then we have what here? Minus 6x. Then here, minus 3 delta x. Because delta x cancels delta x here. Similarly here, delta x cancels 1 up to 2. We have 1 left. So after dividing, we now set limits. We can see then that as delta x tends to 0, which is the condition here. That means delta y over delta x becomes dy dx. Hence, we have what here? 4 minus 6x minus 3 times 0. Remember, delta x is tending to 0. That's the limit. Hence, we have the conclusion that dy dx equals to 4 minus 6x, because this is going to be 0, which pretty much agrees with our mental value we got from the very beginning. And this is basically how to differentiate by the first principle, specifically the algebraic aspect of it. It's a lot simple. However, it's rather procedural. You have to follow procedures. And in summary, all you need to do is to introduce delta y and delta x correspondingly, then resolve the fx plus delta x carefully using the concept of algebraic expansion. From then, you can now subtract the original question, which is the f of x. After carefully subtracting, you divide through by delta x. And the last approach is to set delta x to 0 with the limit, and from there indicate your answer. So that's basically how to differentiate by first principles. It's by no way that simple, I must admit, but with constant practice and subsequent study, you're going to find that your proficiency is going to be upgraded. Thank you, and see you in the next one.